So I'm doing a quick soldering tutorial just to show you how to connect or how to solder on these chips to the breakout boards. I'm going to do it two different ways. I'm going to do it one by hand with solder wire, and then I'm going to do it once with solder paste. So to start out, this particular chip, this is a TSSOP 8 chip, and we can't breadboard directly with this, but we can use a breakout board, which accepts a surface mount component and then pins, sort of has pin connections to a 0.1 inch spaced standard dual inline package format here. So once we get this chip on here and soldered and get some pins on here, we can use this component as a breadboarding, as something we can plug into a breadboard. One thing you'll notice, you can kind of see on this breakout board, you can see the traces. So you can see this pad here sort of goes around and connects to this pin here. There's a little silkscreen notch here. So whenever we have a component with a notch, the pin to the left of that notch is going to be pin 1. If we look at the surface mount component, it's something similar. You can see there's a little hole here. There's a little spot where usually it's where the plastic or epoxy gets injected in. But it's used as the pin 1 designator. So this little circle, this little faint circle here that you can kind of see there, that's pin 1. So on these breakout boards, the surface mount pin 1, you see they have the little tiny notch here. So this this pad should be connected to pin 1 on the chip, and then once it's connected, that will become this pin 1 on the board. So obviously these are really tiny. So to do this soldering by hand, you're going to want to make sure you have proper safety stuff, make sure you have goggles on, make sure you're using tweezers. So you should never be touching anything hot directly with your fingers. The other thing, it's really important when we're doing this type of surface mount soldering, is to always use lots of flux. So the biggest mistake students make, I think, is they use too little flux. You can never really use too much flux. It's just, worst case scenario, it's just a lot of mess you have to clean up afterwards, but it cleans up pretty easy. So the first thing I'm going to do is, now that we've identified the orientation, and it can be very difficult sometimes to see that pin. So sometimes if your eyes aren't good like mine, you might need to use your phone or a microscope or something to see where that pin is. Notice that this pin 1 is different. There's a little, so 3 Peak is a Asian brand, and it's got a little logo next to it. Sometimes if you're looking at it, you might think that logo is pin 1. It's not. So it's the actual, it's either a physical indentation in the chip or a little circle. Sometimes there will be a laser engraved pin 1 marking, like a little dot or something. Sometimes also you'll see it on the bottom of the chip. So sometimes if you flip the chip, you'll see like a little feature or something near pin 1 on the underside. Some chips like to have pin 1 indicators on the underside because when these components are placed by robots, the robots usually use a vacuum to suck onto the top of the chip, so they only have a view of the bottom. So sometimes they put the pin 1 indicator on the bottom because it's easier for robots that way to do stuff. But we are not robots as far as I know. So, oops, look at that, I messed it up already. So first thing I'm going to do is just for doing this by hand, for doing it with a solder by hand, is just put a bunch of flux on here. I'm putting way too much flux on here. And sometimes the flux, because it's been a couple years since people have used this, the flux is a little goopy, or it's got some chunks in it, so should probably get new flux here. So just smearing that around on there. I could have actually used more, but I'm tired of fighting with this thing, trying to push it out. And then we're going to take the chip and we're going to put the chip approximately where it needs to be with pin 1 on pin 1. Now I'm kind of working, the thing holding up my phone is kind of a little bit off, so I'm kind of working. It might be a little difficult for me to get in here to get the solder in here, but for now we'll hold that there. So I'm going to take my hot soldering iron, I'm going to clean the tip off on a wet sponge, and then I am going to, this is not the greatest tip for doing this, I probably should have checked before I did this, but so what I'm going to do is I'm going to just get one pin tacked on. I don't really necessarily care which pin, usually I want it to be an edge pin, but I'm just going to tack on one pin, and to do that I'm going to apply heat to the actual little gold pad here. And I'm going to put a little bit, they always say don't apply solder directly to the tip. That's not always good advice. So sometimes you need, just to get started, you need a little solder on the tip. And now we're going to touch that to the pad. Whoop. now look at that. That actually worked pretty well. That's too much. There's a lot of solder there, but we can get it later. But the idea is that now holds the chip down. So we got one pin soldered down. That holds the chip in place. And if the chip had been off, so let me show you. Let me deliberately mess this thing up at the risk of ruining perfection. So. Oops. Okay, now I really goobered it up, right? So now the chip is way out there in space, way wrong. So if we only do one pin, or I guess 2 pins now, what it lets us do is it lets us grab the chip with our tweezers, come back in and add heat, and it lets us lets us move that chip around. So if we had all the pins soldered down and it was in the wrong orientation, we'd be in trouble. But because we're only doing one for now, just to get the position right, it makes it a lot easier. Now I really... Oh, shoot. Now it's all going off the rails here. So that's probably a little too much. I'm just going to clean... You never want to push too hard with these surface mount parts. They're very delicate. So it's really easy to bend these pins. You should never have to use force. If you have to use force, it means you're not you don't have enough heat or enough flux. So I'm going to put the chip back about in the right spot and put the iron back on there. That's pretty good. So pins generally on their pads. It's secured in place here. So now what I'm going to do is I'm going to go through and I'm going to put solder on the other pins. And you'll notice those 2 pins are bridged there. That's okay. We'll fix that later. So for right now, it's just a matter of getting the rest of these pins secured on. And actually, there's just even the solder that's just remaining on the tip is sometimes enough to sort of feed in here. And if we don't want to use too much, or it's going to make a bunch of bridges. But sometimes even just the solder that's on the tip is enough. We want to make sure it actually coats the pins. It's possible to have solder just touching but not actually wicking up the pins. If you see it wick up the pin, that's a good sign. Once I get it to here, one thing I like to do is once I kind of get what I think is enough solder on here to make this work, I kind of just like to sort of take the iron and just kind of sort of lightly sort of drag the iron along the pin on the pad. That kind of looks a little weird to me. So I don't know why that pin looks like it's got a little indent here. Let me zoom in and see. Enhance. It's probably okay. It could also be floating off the surface. So sometimes you want to put a little bit of down pressure and keep doing this. And I might, yeah, now it looks good. Okay, so these pins, oh, that's good. Now it's good for sure. So those pins are all looking good. Now we're going to spin it around and do the other side. I have a bridge there, so what I'm going to do is I'm going to actually just use the solder that's already there, because there might be enough to get all these pins soldered. And also, I'm feeling, when I start to do that, when I start to touch it and it just kind of makes a crystal on the surface, that's usually when I say I didn't put enough flux on here. I want to do some more flux. Alright, sometimes you gotta coax it a little. Oof. Okay, so back to here. I'm just going to slowly, again, not pushing hard. We don't want to scrape at it. We don't want to attack it. We just want to apply the tip. Get some heat on there until this thing starts to melt. And this is kind of being a pain. Sometimes the circuitry that you have internal to the chip can affect how easily it melts. Sometimes, like that pin might connect to a big giant piece of metal on the wafer inside the chip. And so some pins, especially when they're power and ground pins, can be a little more difficult than other pins to actually get them to melt. Okay, and this one still has, it's not all coming off. I tried to use the solder to get these other pins. Now I got the other pins. It's still not coming off. So we got to clean this up. So the way we clean up a bridge is we use wick. So we have solder wick here, and you know, inevitably, right, the person who used this before us left a bunch on there. That's actually fine. Sometimes I actually don't think that's that rude to do that, because sometimes people are using it for something else. But what we want to clean in, so we're just going to take our scissors and we're going to snip off the stuff that already had solder wicked onto it. Then we're going to apply flux to the wick. This is really important. A lot of people don't do this step and it messes them up. So we're going to apply. Really got it. This flux is driving me nuts. So one other thing you can do a little bit is sometimes you can put if it's tiny flux, you can actually put it. You can feed it into you can clean out the flux syringe using the wick. So now I like to leave enough. If you don't have enough copper length here, what's going to happen is the copper is gonna get hot and it's gonna melt this plastic. It looks like it's already happened in a couple spots, but you want a little bit of length just so it's not really hot back at this plastic end. And then take your iron, and we're gonna want to apply heat. Now here's the main thing is we're gonna apply heat to this braid and then get it to wick up this solder. And we whoop, see that go? Okay, then we pull it off. Now the biggest way students make a mistake is I kept heat on the braid and I pulled the braid off with the iron. If you pull the iron off, very quickly this braid cools down and the copper solidifies, and then you're going to have a chip dangling to your thing. So actually I can show you what will happen if you do that. So if you see what happened, right? If I let the braid cool down before I pulled it off, that happens. And if that happens, the worst thing you can do is start yanking on it. What you want to do is you want to go back and add heat until it remelts and then pull them both off. And now I'm a little worried. I sucked a lot of solder. Maybe I sucked too much. Usually you did not suck too much. Even when you think you sucked so much solder off that there's no more solder connection, that's usually not the case. But just to be sure, I'm going to kind of go back and just grab these pins a little bit. You know, I might add a little more solder. I just like to put a little on the tip here, and then just get it, yep. And then come in here and just touch it. Let the flux do its job. Just touch it to those pins. Our focus is kind of getting a little weird here, but there we go. So just touch it to those pins and let the solder wants to cover the pins. The solder wants to cover the pads. So the flux helps make that happen. So just add heat and let it go where it wants to go. Okay. Now I'm pretty sure this is pretty good. Now we can check. Sometimes tilt it at an angle, kind of look. There's kind of a little bit of a goober on that pin there. And it's just burned flux. We've been playing with this thing so long, the flux kind of started to kind of cook on us a little bit. So now I'm going to clean this up. I'm just going to get a brush with alcohol. So we have a little alcohol dispenser, and we're just going to brush alcohol on this. And again, we're not trying to scrape. It's not an abrasive thing. It's just we're just working that alcohol and getting it to dissolve the flux. And we can see a lot better. It looks pretty good. So looking at these, it looks pretty good. The main concern we have is if the pins are floating off. If we didn't get this chip on there flat, sometimes the pins will be floating off the surface. Oops. So that's our biggest concern is if the pins are touching the surface and we went through this process, odds are it's going to be fine. It looks pretty good. And those pins might have been off a little bit when I did it because I kind of messed it up and redid it, but Actually, I'm a little worried here. That pin might be off the surface a little bit. I think our chip might be tilted a little bit. Just a little. But I'm a little worried about that third pin there that you see. So if it's off the surface a little bit, we can use hot air or we can just add flux, but this is just something I'm checking. Boy, I really goobered this thing up, didn't I? So put some heat there. Actually, I should use more flux. I should use more flux. So now that I had a worst case scenario, well, this is not worst case scenario, I guess, but you know what? I'm just going to use a jar. I got some in a jar, too. Big old glob of flux. Okay. And then we're going to get a little bit of solder on here. Not too much. A little bit of solder on there. What I want, there we go. That's that's definitely getting it. Make sure the other ones are too. I think that one's okay. But yeah, again, because this thing is lifted off the surface a little bit, it's pretty easy for this to be. I worry about that one. I worry about that one. Okay, so because I'm having this issue right now with it lifted off the surface, again, this is the problem. I should have checked that it was flat when I just had one pin soldered. I'm going to switch to hot air now and just give it a push. So the hot air gun shoots out a very hot stream of air, as you may have guessed. Sorry, one sec. Recording a video. One sec. So I'm just going to hit this with hot air until the whole thing gets melty, and then I'm going to keep a little bit of just light pressure on the top until that thing pops down. Sorry, the hot air pump is kind of pushing the table, and I think we just got it. I smell kind of burning, so I'm a little worried now. I think that got it, so we'll take it off. And we'll call it good there. We'll come into the next video and I'll finish this up. Okay, so in the in-between video here, I just kind of cleaned this off, and it looks like we did get it down. It was a little hard to see working with the camera, but it looks like the chip is down flat now on there. It looks like we got a good solder on all those pins, and it's not too burned. It got a little hot there from the iron, or from the hot air. So the next thing to do is to put the pin headers on this. And I'm going to zoom out for this part. So the pin headers typically come in pin strips like this. These are breakaway headers. So what you can do is you can. So I'll use snips, but you can, if you're good with getting your fingernails in here, you can break this by hand. So we need 2 sets of 4. So I'm just going to go in to this. Oh, you got to be careful. Wear goggles for doing this. And point. So if you break it by hand, it doesn't necessarily matter that much. But so we got our 2 sets of headers now, and when putting headers on, it's the same as the soldering the pins. Once you get more than 1 pin soldered down, it's really tough to move stuff around. So we usually start with doing 1 pin at a time. So you can do this by hand, or the other thing you can do is you can use a breadboard to align this. So the other option is you can take a little mini breadboard, and you can, if we look at this chip, and we see, so this is not, oh yeah, so that, oh yeah, that is, so that is a 0.3 inch spine there. So it's 0.3 inch between these rows of pins to straddle the spine of the breadboard. And so what that lets us do is, if we just stab these, sorry for my gnarly cuticles here, if we just stab these into the breadboard, oh, it's a little tough to push these in, so, oh, see what it did there? That'll happen too. This breadboard's a little stiff, so I'm just gonna use some flat. Oh, now I goobered it all up. All right, undo. We'll show you the other option. Put this one in just gently, don't push it in yet. I gotta make myself another set of 4. So I have the 2 rows of 4 just set on there. Now what I'm gonna do is I'm gonna take this and get the pins resting in here. Okay, get the pins resting in there, and then now I'm gonna push this whole thing down. I'm going to try. I'm going to do it off camera because this breadboard is just really stiff. Okay, so push that in there. Now what's going to happen is, because this is already plugged into the breadboard, it's going to keep that all nice and aligned. So it is possible for these to sort of tilt in and out through this breadboard. So sometimes you got to kind of finagle it, but if you're able to get it into the breadboard while you're soldering it, it usually works out okay. So now we're going to add flux, lots of flux. I'm going to use the needle approach again here. So just got flux in this container. So we're just going to put lots of flux on these pins. So again, normally biggest problem students have is they use too little flux. Too much flux is usually not an actual thing that's an issue. So now I'm going to go and I'm going to, now because this is already in a breadboard, I can just go ahead and kind of solder these and just assume they're all aligned. If it wasn't in a breadboard, I would probably want to, just do 1 pin and then check it and sort of move it with my hand. You know, touch the cool pins with my finger to move it around, while applying heat to the 1 soldered pin to get it nice and aligned. So I'm just going to apply heat to here, feed in solder, and we're looking for it to form a nice meniscus. So I'm going to zoom in. This is really important, and I know you've done this type of soldering before, but this is a really critical part of this, is to see what a good, I'm going to show you, I'm going to try to do a cold solder here. I tried to do a cold solder and I couldn't get it. Okay. That might be a cold solder. Nope, even that one went. Holy cow. There's too much flux, too hard. But sometimes what will happen is, sometimes you'll get a ball of, like that. Maybe that. No, I wouldn't classify that. So the flux actually performs a little thermal. The flux kind of gets a thermal. Yeah, see, that's just too good. So the flux is allowing heat from the pin to transfer to the ring too. So it makes it very difficult to get a cold solder. So I'm not going to be able to show you a cold solder, I guess, but I'll still try. I'll try with all of these to get. Okay, that's a cold solder. So there's solder on the pin for sure, but it's not actually touching the ring. It's not actually wicked on the ring. What you want to see is you want to see this solder form a meniscus. So I'm going to show what that looks like. You want it to sort of instead of sort of bubbling out like this, like making a ball on there, you want it to sort of to wick all the way in a continuous curve to the edge of the pad. So see what that looks like, right? See how it spreads out instead of forming a ball? If you see a ball on the pin, instead of that sort of spread out to the outer edge of the pad, then that's probably a cold solder. So I always want to make sure you got a good solder connection. No, we're making a lot of smoke here. I'm also, we're making a lot of smoke, so I'm going to turn on the snorkel. So sorry about the noise, but we're snorkeling here. So the snorkel is just going to suck. You can see when we make smoke, it sucks it away. See how it's going to the snorkel now? The other thing is, when you are soldering on a breadboard like this, you don't want to apply heat for too long. If you apply heat for too long, you can actually melt the breadboard. So you want to, you always want to kind of work a little fast when soldering. Lots of flux, work quick. So now I'm going to pull this out of the breadboard, and you can see those are pretty aligned. That's a pretty good, not perfect, they're kind of tilted in a little bit. But that's a pretty good alignment because we had it in the breadboard. And the nice thing is it should make it pretty easy to push it back. Did we melt this breadboard at all? Doesn't look like it. I think we're okay. But once it's gone in once, you can push it in again. So that's that, and I'm just going to clean this off. So that's getting the pins on. So last thing is just to do another alcohol clean. And if you get these really clean, if you get all the flux off of these, sometimes you can see the markings on the chip. You see the markings on the chip kind of go with the lettering on the chip, the 3-peak and all that. That's a very thin layer produced by a laser. So any little thing that kind of coats any little film that coats the surface of the chip makes it pretty much impossible to see that lettering. If we get it clean enough, though, and maybe sometimes it's good to take a Kim wipe. Sometimes it's good to also clean the bottom of the chip just because you have residual flux that's on there. So if we take this, let's just give it a Kim wipe here. So Kim wipes are lint-free wipes. They're really good. If you use a lint wipe, you can kind of get little hairs on your chip, and hairs aren't good for solder. So wiped it with a Kim wipe. Oh, look at that. Lettering came back. So it's pretty clean if lettering came back. We can check all those solders. Everything looks good. So that is a soldered op amp. And now we can just use this like any other op amp on a breadboard. The other way to do this is with surface mount. So surface mount. So to do surface mount, we use a paste. So this is a jar of paste. It expires fairly soon here. These jars, hold up. If we open these jars, you can see, so solder paste is basically just little balls of solder that are suspended in flux. So they're little mini balls of solder suspended in flux. If we zoom in, can we see the little ball? You can kind of see a little texture. Not really. There's other videos where you can see the little ball, but I think we tend to get good flux too. Good flux has tinier solder balls, so you pay more for tiny solder balls. And so I'm just going to do another one of these. So same thing as before. Take the breakout board, make sure it's oriented right, and then take a chip. Make sure the chip is oriented right. I need to. Okay, so we got to rotate that. Oops. Okay. So now what we're going to do is, the nice thing about flux, about solder paste, is it kind of has flux built in. Sometimes I found it's good to just put a little bit of flux on the pads anyway. So I'm gonna do that off camera really quick. Just smear a little bit of flux on here. And we don't need nearly as much this time because we're going to be using paste. So, but sometimes it just helps get that little bit of fouling. It's not as big of a deal when it's actually, sometimes gold does have fouling. Gold, especially if you live next to a freeway where there's a lot of diesel trucks, you get a lot of sulfur on the surface of the gold. It's kind of nice to have flux. Kind of helps clean it all up a little bit. And so now we're going to do this paste. So and I got 4 minutes, so I have to go to another meeting. So I'm just going to get a needle of some sort, and I'm just going to grab a little bit of this paste and smear it on the pins here. And I want the paste that I smear, see, I'm not being very precise, but I want it to extend beyond the pins. If you smear it and the smear of paste is limited to just where the pins are, then those pins on the edges tend to not get enough. So, and this is actually too much. So it doesn't take much to get this. I usually use too much, and that's okay. If we got to clean it up, we got to clean it up. And while we're waiting, I'm going to turn the hot air back on. So now we're just going to set our chip on. The chip got jostled here a little bit. So we're going to set the chip on there and get it aligned a little bit. And one thing you'll see is this hot air is very forgiving in terms of getting this to sort of realign itself. Let me try to get a better focus here. Okay. So we're going to hit this with hot air. So the tip of my hot air gun is I'm just circling it around, trying to kind of evenly heat this board. What's happening now? It's kind of getting blown as they got melty. It kind of blew the chip, so I'm going to give it a little tap. A little tap. And then whoop, that looks good. So you notice the flux didn't wick down those pads very much, but that's probably good as is. We got to check for bridges. Looks like we got some bridges here, So we did a hot air reflow. Now we're just going to come back with an iron, and we are going to use extra flux here. Oops. Be careful about heat too, because that pad can be. After you do hot air, anything that was behind the hot air is going to be hot. Ah, shoot! I just hit my phone with the iron. So now we're going to just come back in. And if we had too much solder, we might have to braid some of this off, but I'm just going to try just raking it. Okay, well that's a bridge I'll probably have to clean up, but you get the idea. So put down some paste, put down some flux, put the chip on, give it some hot air, let it all melt, and that's the magic of hot air rework. See, that's pretty good, right? Okay, that's the way to do it that way. Thank you.